Okay, so here we are with our fourth example of integration by use substitution. We're going back to indefinite integrals now, but we're sticking with Sallows, Hill, and Etkin because it's so great. And we're going to see a little bit of a curveball here, something that we haven't seen before, and we're going to use a trick that we haven't seen before either. But I want you guys to, what I want the takeaway from this video to be is that if you're confronted with something new and strange in math, you can always stop and think your way through it. We don't have to panic. So we'll be talking about the process that we use to come up with this trick, although of course I didn't come up with this, but sort of the process that is behind this trick. And we're always focusing on process over results when we're learning math. When we're writing the test, of course, the results matter very much, but when you're learning, it's all process. So without further ado, here we go. We're looking at the integral, the indefinite integral of x times x minus 3 to the power of 5 dx. And I'm going to see, okay, this looks like a u substitution integral. I'm going to set my u equal to x minus 3, but now my du is actually just going to be x, because the derivative of x is 1, and then I get this factor of a dx in there. And this is where it starts to look a little bit weird, because now when I go to do the substitution, I get, well, my u to the power of 5 and my du, but I'm stuck with this x here. And what's going on with that? How am I going to deal with this? This is not what I'm used to seeing. I'm used to seeing everything in terms of u. So again, instead of kind of panicking about this, and I'm going to think, well, if I want to do an indefinite integral in terms of u, because I have this du here that I need to match everything with, well, I can just use this expression here to solve for x in terms of u and then substitute in there. So I can rearrange this thing and say, well, if u is equal to x minus 3, then x is going to be equal to u plus 3. And rewrite this thing yet again as now the integral of u plus 3 times u to the power of 5 du. And of course I can distribute in this u to the 5, and I'm going to get the integral of u to the 6 du plus 3 times the integral of u to the 5 du, using the fact that integrals are linear, of course. And since these are antiderivatives, I can just go backwards from the power rule here, giving me u to the 7 over 7, plus now this is going to be 3 u to the power of 6 over 6. And of course I can cancel these and put a 2 here, and then I'm adding a plus c. And we only need one c, because each one of them brings along with it an arbitrary constant of integration, but we just add them together and merge them and say this is our plus c.